Okay, let's try to again get some feeling for Biot-Savart law and see what the direction of the magnetic field looks like for different points. But this time we're going to move along a circle that's in the same plane as the element of current, so in the XY plane, and we're going to see what the magnetic field looks like at different points. So let's take first this point right here on the x-axis. So for this point, the ds vector and the r hat vector point exactly in the same direction. Remember, the r hat vector points from the element to the point where you want to find the magnetic field. So that means since these two vectors are in the same direction, then the magnetic field here is equal to 0 because ds cross r hat is 0. The angle is 0 degrees between the two vectors. So the element of current cannot produce any magnetic field at any point actually along the same line of that which the element is located in this direction. Okay, so dB is 0 in that case. Now what about if you increase the angle theta a little bit and go to a point over here? What direction would the magnetic field be over here? If you take ds cross r hat, you'll get a vector pointing in the k hat direction. So it'll have a magnitude mu naught I over 4 pi r squared. The magnitude of ds cross r hat is the magnitude of ds. The magnitude of r hat is 1, and then times sine of the angle between them. So you get sine theta. So that means when theta increases a little bit, remember what happens to the sine when the angle increases a little bit. It starts to increase until you get to 90 degrees. So let's go to 90 degrees. When you get to 90 degrees, you get the maximum for the sine. So that's why the vector has the largest value over here. And as you go further, the magnetic field will get weaker because the sine gets weaker when you go between 90 and 180 degrees. You get to 180 degrees and the angle now is 180 degrees between the ds vector and the r hat unit vector. So the magnetic field is 0. So the magnetic field is 0 also in the direction opposite the current, all along the axis. So any point on the axis of the element of current has 0 magnetic field. The element of current doesn't produce any magnetic field along its axis. When you go to an angle bigger than 180 degrees, now the r hat unit vector points this way, and now when you get the cross product between ds and r hat, you put your fingers in the direction of ds and you curl towards r hat. Now the direction of the cross product reverses and it's now in the minus k hat direction. And if you go further to 270 degrees, it gets bigger, and it's bigger in the minus k hat direction. When you go more between 270 and 360, it gets weaker until you get back to 0 degrees and it gets 0 again. So this is what the magnetic field looks like at different points if you go along a circle around the element of length. So it's much more complicated than it is the case for the electric field due to a point charge. This is much more complicated because of this cross product.